Okay, so we just start in the problem. And then I think he's like gonna go over.
For 2, I thought I got +1, but I'm not sure.
Yeah, so 2 is gonna be +1. Let me I'm not used to doing this online. Give me a green check mark when you're done with 1 and 2. Once I start seeing like quite a few, then I'll go through them, because I think these 2 should be pretty quick. So take another like 10-20 seconds and we'll go over.
Also, I'm gonna try to be as quiet as possible.
Number
but like,
1,
I'm so
what do we think number
right
1 is? Yeah, Malik said it. Yeah, so E. So why is it gonna be E? Yeah, fluorine is gonna be the most electronegative, and carbon and hydrogen have very similar electronegativities, and the biggest difference is going to be coming from the highest electronegativity, So that one's going to be E. I can just highlight that. Sure. How about number 2? We said B for +1. And so I know we've went over this quite a few times, but you can just say it in chat. What's going to be the formula? So FC, or formal charge, equals what? Yeah, so what are the numbers? If you want to say it out loud, you can too. Yeah, so 5 minus 4 minus 0. And because you have 4 bonds around that nitrogen, and you have 0 lone pairs coming off of it, so 5 valence electrons minus 4 minus 0, that's going to give you +1. So it's going to be this one.
I have a question, sorry.
Yeah, Natalie, what's up?
One of the practice for like chapter 1 or 2 that you posted on the website, for like number 6, it says, what is the formal charge of O and the compounds below, and then it gives you like O and like 2 H's and stuff.
Yeah.
So, because like when I tried doing it, I know there's like no lone pairs. Are we just supposed to know there like how many lone pairs O should have and just do it based off that?
Pretty much, yeah.
So if it's not provided, I should just know that there's, oxygen is 6, it has 6 valence electrons.
Yeah, it should have 2 around 6 valence electrons and probably around 2 lone pairs. And if you only see like 1 lone pair, if you see like 3 bonds or something, that should be a giveaway.
Okay.
And what's up?
Sorry. So how this one is like it has oxygen in the middle and like 2 H's on the side, and it's like bonded to those H's, but there's no lone pairs. So what I did, I just kind of knew that how many lone pairs oxygen should have, and I just I did 6 minus like 4 lone pairs minus the 2 hydrogens that are provided, and then that's how I got the answer.
Yeah.
Okay.
Yeah. Yeah, all of them are going to have 8 valence electrons. No, they have 8 electrons around them, but the amount of valence electrons for just the molecule, that's going to be kind of different for each one. So like carbon has 4 valence electrons, hydrogen only has 1. So let's try 3 and 4. Let's actually go just number 3 right now, because 4 is a weird one. Yeah, Hamza, you can find out valence electrons from the periodic table. And sorry, let me just go over to ptable.com. So over here, the way you know valence electrons is you can look at if it's in the first group right here, that'll just have one valence electron, and then the second group will have two, and then skip the transition metals. Group number 13, see how it has a 3? It'll have 3 valence electrons, and then 4 up and down, 5 up and down, 6, and so on. And then the halogens will have 7. Yeah. Yeah, so if you couldn't see, it's this hydrogen, or this oxygen that's starred. So we have, just like the last example, you have nitrogen with 4 bonds around it, and you'll start to notice a pattern. Like if you see nitrogen with 4 bonds, it has a +1 charge, you know. Oh yeah, number 2 was B. Yeah, so nitrogen with 4 bonds, you're gonna have a +1 charge, and then this oxygen, it has 2 bonds, 2 lone pairs. That's very characteristic of it having a formal charge of 0. And if you wanted to do it out, you could say, okay, oxygen has 6 minus 2 using the double bond, and then minus 4 electrons. 6 minus 4 minus 2 is going to be 0. Any questions on that? All good? Okay. Try this one. Yeah, for formal charge, you count each electron. And you'll see that come up again with something called radicals. Radicals are going to be like single electrons. Give me a green check when you have an answer. But don't say it yet. Give me a red X if you want more time.
Someone's like, you guys tell me where to find the green check.
What do we think the answer is? Oh, Sydney, so if you go at the very top, you see where it says like participants? You can click on that, and then at the very bottom of that window that just popped up, at the bottom you can see like hand raised. Yeah. Yeah, are you just testing that out? Yeah, so okay. We're thinking P. Does anyone disagree? Anyone disagree? Going once? Going twice? So let me, before I explain anything, when I took this class, I had this exact question on my exam, okay? And I was like, oh, carbon has 4 valence electrons, and so it has, 4 unpaired electrons. But that's not right. I got that question wrong. The reason is, let's say we have carbon, okay? 1 second. Sorry about that. So watch this. We have carbon, right? We have carbon, and I remember my thinking was, if you go like this, you have 4, right? But again, it's not that. Yeah, I know. I was too, right? Yeah, Aisha's got it. Yeah. So remember those like those things, how you have like 1s2, you have 2s2, and then 2p, it's gonna have 6, right? Oh no, 4, because you have an atomic number of by the way, the atomic number on this is wrong. Atomic number is supposed to be 6. So you have 2. You have 1s2, 2s2, 2p2, right? So the electron configuration, you're going to have these two as paired, right? These two as paired, because remember, you always go from the energy levels. So you have, this is your S. Let me draw that a little bit bigger. This is your S. You have one electron and another electron, right? Those are paired, they're opposite spins and all. And now we have a higher thing with the P's, right? So also you have 2s2, right? I don't know how you draw those, to be honest, but you'll have 2s2 also. But let's look at how 2p2 will look like. Remember how you start filling electrons from left to right, and then you start pairing them, right? Wait, am I doing this right? I don't actually know if I'm doing this right. Someone help me out. Is this how it is? Is it
You answer 2?
Yeah, the answer is 2.
Okay, then I believe that what you do is you fill up the P levels, and since the Aufbau principle or some exclusion principle, you can only fill one electron at a time in the P level. You would do 2 up arrows because they have an upward spin, so then you have 2 unpaired electrons there. That's the only way I could have thought of it.
Yeah, I remember explaining it one time as there being 4 electrons here, and so like 2 of them would be paired, and then the other 2 would be unpaired. Aisha, that's what you were saying. Yeah, that's wait.
Randy, I think you're right. I think it's the as or like the 2p and then the each one.
I think yeah, it probably is like this. Okay. Yeah, you're gonna have this and then this. Sorry about that. I'm just forgetting the old stuff, So you're gonna have 2 electrons that are like this. So these 2 or 4 of them are gonna be paired, and then these ones over here are gonna be unpaired.
Sorry.
And as you can imagine, I actually had this on an actual exam, so we were not too happy about it. So, right. Yeah, that's how you see the unpaired electrons within an atom. Don't expect every question to be this convoluted. Maybe, just maybe, you might have one, but just try, give it your best, and just do as good as you can. Is that good enough with yeah, so the answer is going to be 2. Forgot to mention that. The answer is going to be 2 because right here, come on, right, I think it's going to highlight. Oh no, it doesn't. Okay. Answer is going to be 2 because over here you have 2 electrons in the s orbital. You have 2 electrons. You have 2 more electrons, and then the other 2 electrons. These are going to be unpaired, and so that's where you get your 2 unpaired electrons, right? Yeah. So again, don't expect every question to be like this. Don't expect you'll maybe have one question that's hard like this. But let's move on. This should be. Okay. Try number 5 and 6. Give me a check when you have it. You guys got both of them? I'll give like 10, 20 more seconds. Okay, so 5 should be a gimme by now. If you have a nitrogen that has 4 bonds around it, it's going to have a positive charge, right? I'm not even going to ask that for the 3rd time, right? So the real new thing here is number 6. So how did we do number 6? Can someone try to explain that? Give me like raise your hand when if you want to, or if you don't, just unmute yourself. Yeah. Go ahead, Murray.
Can you hear me?
Yeah.
All right. So is it basically you're looking for whichever one? I mean, basically you're just trying to find a triple bond first, because that's usually where there's sp. And so at 4 and 5, they're both triple bonded, and they don't have any hydrogens to be like extra hydrogens to be attached to. So like each carbon is only attached to one, like 2 other things. And so both 4 and 5 are sp.
Yeah, exactly. So if I were to zoom in on carbon 4, yeah, bravo, Murray, come on. Good. So let's say carbon number 4. Okay, I have 1, and I have 2 other things. And I say things as in like any type, constituents. You can think of constituents, So 2 like groups around it, and a lone pair can't act like a group. So I have 2 things around it, and remember how I said however many things you have around an atom, your superscript should add up to that. Yeah, so radicals are weird, man. Radicals are weird. I don't think a radical acts like a group. No. The practice test I think it's 24 questions. But we've actually been going through this quicker than the other topics. So, I know I said 4 o'clock, but if you want to stay, I'll keep on going. Again, you can, if you need to leave, that's totally fine. This is supposed to be P1, not 2. So if you have 2 things around it, it's going to be S1, P1, right? And so same thing goes for carbon 5, and so you're going to have B being the answer. Thanks, Ken. You guys good on this? Yeah.
Right. Someone said, I'm saying until we go through the whole book or until Raina gets tired.
Again,
I don't know who can see the chat.
Just stop me. Just raise your hand, unmute your mic, whatever you need to do. Give me a green check when you're good with these 2. I'll give another 10 seconds or so. Okay, what do we get for number 7? All right, so kind of all over the place. We're looking for
Everyone
SP2,
said E except for one person.
just to remind everybody,
He
right?
said, we all over the place.
So what did we say about getting hybridization? We look at how many things, right? Can I have someone explain how to do it for this carbon right here that I underline in green?
Yeah, so it's attached to 2 hydrogens and a carbon, and it has 3 constituents, so it's sp2.
Yeah, exactly. If you have 3 things around it, it's going to be sp2, right? And now how about purple?
It's only attached to 2, so it's sp.
Yeah, exactly. Good job, Kat. So we got sp right here in purple, and then both of these ones in green are going to be sp2. Does that make sense? Anyone need clarification? All good? Okay. Well, how about number 8? By the way, I got this one wrong also on my actual exam. Or not this question, actually. It was something similar. Yeah, it wasn't worded this way. It had different options, but I just didn't know if they meant by S. Yeah, so it's gonna be B.
Period. That's what I said.
And the reason for that is because what they mean by S
Allison.
is
I got one
literally
wrong so far.
just a hydrogen is gonna be just S. So let me draw this out.
It was number 7 because I got confused by the bonds. I did not think it would be SP for the middle one. Just saying.
I'm not gonna draw the carbons. I'm just gonna draw it this way. So we have that's bad. So we have hydrogens, right? So remember how I actually had your professor, Dr. Trivedi. I had him for orbital 1. So if we have something like this, we talked about how this carbon in purple is going to be sp2, right? We kind of talked about that in the last one, right? So the way I would do the hydrogen is pretty much the same way. It only has one group around it. There's no other groups around it, right? So that number 1 has to correspond to S something, P something. And so you go S1, P0. You can kind of think of it that way, right? And so it's just going to be just S, right? Does that kind of make sense? If you have just a hydrogen, it's just going to be Okay, I got you. I can explain that now. So when they say orbitals overlapping, that's kind of a fancy way of saying what are the 2 hybridizations, right? Because let me try to draw this. So let me try to draw this over on the right. So if I have like ethene, right? So I have a carbon double bonded to a carbon, right? But what does that actually mean? That means that double bond that we draw, let me erase these. That double bond that we draw, it's pretty much going to be like, let's say I have these 2 carbons, right? This carbon on the left side is going to have like an orbital that it, or no, not that far. It's going to have, where'd it go? Okay. It's going to have this orbital kind of coming out, right? And this is going to be that sp orbital, okay? It has one p subshell, then it has one hydrogen and another hydrogen. If this looks confusing, don't worry about it, but just know that they're going to be overlapping. Okay. The orbital from this carbon right here is going to be overlapping with the orbital from this carbon. And the same thing goes for if you have a hydrogen over here. Let me make this good. If you have a hydrogen over here, right? This hydrogen has a little orbital, right? Let me do that in a different color. Yeah, so this hydrogen has a little orbital coming out, and this carbon is also going to be having an orbital coming out. And that the overlap of those orbitals is going to be what makes your bond. It's okay if that didn't make sense. Just know if they're asking about orbitals overlapping, that just asks about hybridizations. Okay. Yeah. Okay, so let's try number 9. Exactly, Hamza. Is that how you pronounce your name, by the way? Hamza, or is it Hamza? Okay, Hamza. Oh yeah, my bad. That didn't go over all the way. Let me put this there. But I'm guessing you could tell it's just bond 1, 2, 3, 5, or 4 or 5. And so,
speedy. Like,
why is it gonna be number 5?
I mean, I was already done. Like, let us think, girl.
Bastiana, can I have you try to explain, maybe, if you want to? Yeah, exactly. Triple bonds are just shorter. Since you have more S character with those, they're gonna be the shortest. If you don't want to know why, just know triple bonds are the shortest. The strongest and shortest, exactly. So that's gonna be bond 5. So let's try number 10 and 11. By the way, how's the audio? My fan is like, the fan on my laptop is going crazy right now. Is it good? Okay, perfect.
So Ken said Prime.
Good.
He's funny. I like him.
This thing's loud, man. So yeah, give me a green check when you're good with these.
Which species has its bases? 2 and 4. Sorry, Allison.
I'll give like 30 more seconds. Take your time. All good? You want to go over 10? So, what do we think number 10 is? Actually, you know what? I'm actually able to, like, poll you guys using WebEx. Yeah, okay, poll. So, I haven't really used these much, but okay. So, let's
Hair on my screen.
and
Ah,
so these, like, no one else can see them. Just a way for me to see what everyone thinks. And so, is it,
low-key my screen will be
A,
dirty.
B, C, D, E. Okay, now you should see a poll come up, so just tell me what you think it is.
You getting fancy with it.
And I think you're able to change your answer too. Yeah, so pretty much everybody's getting it. So I think close poll, right? Okay, it gives whatever. So yeah, I guess I don't have to explain this too much. It just says conjugate acid, right? So acid is the big word. It's asking you if you were to protonate this, if you were to add a hydrogen, right? Add a hydrogen plus, what would you get? And the answer would just be C, because if you protonate it, you'll have 3 hydrogens, and that's really it, right? What do we think? Am I able to just do that again? The same poll. They're all no, and then no. Okay, so now number 11. So that's gonna be is it A, B, C, D, E. Okay. But you're answering for number 11.
Allison, I'm gonna sing your song. I decided I don't want to. Just kidding. I can't.
Yeah, so most people are getting this. Good. So can someone walk me through this?
I can.
Yeah.
Okay, so basically what I did was I looked at the H2NO3 and it's positive, so it accepted hydrogen.
Exactly.
So
So
then-
you're at the product side right now.
Yeah, so then that's your conjugate base. So then on the opposite side,
Yeah, acid.
or yeah, my bad.
Yeah, this is your conjugate acid. And so okay, I can't write.
Oh.
So this is your acid.
Is
Right,
it?
and so
Because I
what
don't
does
know,
that mean your base
urethra.
is?
On that side or the other side?
The right side, yeah.
Oh, I did that wrong. Never mind.
Oh, that's okay. So we can go through it. So this is gonna be your base, right? Because the base is what's taking the proton, right?
She said, whoopsie.
Oh, okay.
Yeah, and so this is gonna be your base, right?
Mhm.
And so the base, if you're gonna be taking this proton from the H2NO3 on this other side, which one's gonna be the conjugate base? If we have an acid over here,
Oh,
which one's the conjugate base? Which number?
2.
Yeah, exactly. This is gonna be I circled this one, but I actually meant to circle the bases. So this is gonna be your base, right? These two are gonna be your base. Because if you think about it, this only has 1 hydrogen, right? Let me draw this way. So this has 1 hydrogen, right? This has 2 hydrogens. That means HNO3 took a hydrogen, and over on the other side, you have 1 hydrogen here and 2 hydrogens here, right? So that means HSO4 is going to be your base. So you have 2 and 4. That's going to give you C. All good? So this is how it's going to look. Yeah. So now try number 12. I can actually put a poll up for that too. I'm actually liking this poll option. Makes me know how much like people know. No, I don't want to say
Heavy one.
4 questions. No. So. Okay, this says number 11 again, but I mean number 12. number 12 for this one.
I think I did this one wrong, but I do
Looking for the highest pKa. Another way to say that is the most or the least acidic atom, or least acidic molecule.
I'm gonna say this hard. Ha.
So do we need to have this number of the pKa's memorized for this one, for like this, a question like this?
So it would be good to know the pKa's, but there is a way to answer correctly without knowing the pKa's.
Well,
Remember those cardio rules for the guidelines?
Yeah, charge is first.
Think about that.
So
Look at charge, look at the atom, all that. Yeah. Can someone let me know, is there a way you can change the answers with the polls?
nah.
I'm pretty sure once you select it, it's locked in.
Okay, sure.
You just
so
can't press
confused.
submit if you don't want to submit it, right?
Yeah. Do you want me to close it and reopen it then? After you take some time to... Oh, you see, the charge of the atom that's acidic, that has the acidic hydrogen atom. Do you guys want me to close the poll and reopen it? Okay, so from this, I'm getting quite a bit of A's, quite a bit of D's.
I don't think it's A or D. Oh, with the highest pKa. Oh my god, I'm so stupid. Oh, that's awkward. I
A
thought it
general
meant most
sense,
acidic.
okay. These two.
So E is
Right.
definitely the lowest. That's awkward. Oh, I think it should be C then. Oh.
Okay, so I'm gonna go on with this.
I'm confused.
Okay, so remember cardio, we have charge, so a plus charge is going to be pretty acidic, right? We have plus charge down here, and if you want to be super safe, you can always compare these two atoms to each other. So the best thing we can compare the letter B with is letter A, because if you have two of the same exact molecule, but one of them is protonated and one of them is not, then of course the more protonated one is going to be more acidic. And so since we're looking for the highest pKa, we can cross that out, right? Because plus charge is going to be more acidic, but we're looking for less acidic. So you can cross out the more acidic one. And now, what else can we compare? What can we compare A with?
With B and C, because they're attached to like an N and O or C. Does that make sense?
Yeah, exactly. So we can also look at the atom, because everything now has no charge, right? We can look at the atom right here, and right here. And again, we're looking at the atom of the atom that has the acidic proton connected to it. So which one's going to be more acidic? O or N?
Well, it's A. It is A. It is the one.
O. Yeah. O is going to be more acidic. And so again, since we're looking for the least acidic, the highest pKa, we can cross out D, we can cross out C, we can cross out B. Does everyone see how I got that reasoning?
Yeah.
Does anyone need clarification? I don't mind going over it again.
I just had a quick thing. I don't know if this always works. I just want to make sure, because it worked this time. I usually look at the age and see how willing it is to leave. Is that does that work?
Oh yeah, that's how you judge acidity.
Okay.
Yeah, it's basically based off of those cardio rules. There was another person.
So oxygen wants to hold the hydrogen more than the nitrogen. But when you compare the option B and C, which one is more acidic?
Nassim, it's not necessarily. The oxygen actually kind of wants to get rid of that hydrogen because, and I'll show you why. So,
I won't look.
One way to think about acidity is how strong the bond is between the atom and the hydrogen, right? So if I had oxygen connected to hydrogen versus nitrogen connected to hydrogen, right? Remember, if we're looking at across a period, right? So C versus N versus O versus F, right? When we look at a period, do we look at size of the atom or do we look at electronegativity?
Size of the atom?
No, not. So we look at size of the atom if we're going down the group, because the size of an atom gets really, really big as you go down a group. So like fluorine and chlorine, the difference in size between those is so huge. I think P-table actually like shows this. So if I click on fluorine and I go on electrons, I think electrons, yeah. But if I go on chlorine, that's okay. Just take my word for it. I don't know how to show it, but the size of the atom gets so much bigger when you go down a group, and then when you go across the period, it only gets a little bit smaller. So electronegativity is going to dominate when you're going across the period, and size is going to dominate when you're going down a group. Okay, so since we're looking across the period, we can think, okay, oxygen or nitrogen has a dipole, sure. Oxygen has a much bigger dipole, right? And so if you have a really big dipole, that bond is going to be really weak. Making sense? So across the period, let me type it in chat. So across a period equals electronegativity. Compare electronegativity. Down a group equals compare size. And this is of course of the atom, the acidic atom, right? It's all going to be of the acidic atom.
I'm tired.
Thank you. But if you compare the option B and C, which one is more acidic? They both are connected to the O. So
okay. So that's when you get to resonance. So B looks like this, and C looks like this. And remember how if you have a double bond next to the acidic atom, then there's going to be more resonance, and so we have a bigger volume, and so it's more acidic. Does that help?
Thank you.
Yeah, no problem. You guys want to move on?
Yes.
Okay. Let's don't worry about this saying 18. It just does, I guess. So let's go 12.5. So remember, actually, yeah, just go on. See what you get for these two.
I think.
Give me a check mark when you're good with them.
I won't say.
And I don't really like that polling anymore because it's just weird. It shows weird results. So one thing I want you to notice is that in this question right here, 12.5, every single molecule is the same except for actually here it's a hydrogen. So everything is the same except for just what's connected at the very end. Yeah, see, this is where things get confusing. So I'll tell you it's not A.
What?
Okay, so Aisha, that's a good question because I used to think this too. When you have something like CH3OH, remember how we've this is bad for you to remember how we've said how carbon bonded to oxygen or carbon bonded to hydrogen is going to be very, very not acidic, right? It has a pKa of like 60 or something, which is super, super high, right? So in this case, it would be a little silly to talk about the hydrogen on the carbon being acidic, right? And so this we would be talking about only the oxygen being acidic. Yeah. So yeah. Oh, did you mean something else? Would it ever get confusing? Do you mean with like more than one thing being acidic? It can, but don't worry about that for this test. Pretty much you would use the same logic. You would think, okay, if I have an NH3 or an NH2 group and an OH group, then the OH group is going to get deprotonated first because it's more acidic. Yeah. So what do we, yeah, no problem. What were we saying about, yeah, so it's not going to be A, because remember, when we talk about atom, we only talk about the atom that's connected to the hydrogen. So in this case, the atom is the same. Right? When we talk about, you know how there's, C, A, and A is atom, and R, D, I, O, right? Little tail. When we talk about atom, that's only talking about the acidic atom, right? What does this question test you on? Is it atom? What is it?
Should we be looking at the electronegativity of the first atom instead?
Yeah, because this is going to be testing you on dipole induction. Remember how dipole induction, that's going to be when you have electron density being taken from this atom over here. Yeah, inductive effect, exactly. Yeah, that's exactly it, Mary. So all of these are going to be similar. They're going to be acetic acid, right? So charge is the same. And then let's say this is just an X, okay? So X just means a halogen, okay? Yeah, I can, Carter. Or I can, Malik. Yeah, it's going to be D, Amelia. So let's say that X is just a halogen, right? So charge is the same. This is charge. If I can write, just believe me, I tried to write charge. This is going to be, R is resonance. So remember, resonance is this whole thing. Remember that? That's resonance. And then if you have the resonance being the same, all of these have resonance. You see that? They all have that C double OH. Double OH, right? So resonance is the same. Now we need to look at these guys right here. And this is going to be your dipole induction. So let me zoom in. If you have in X, right, a halogen, right? Remember how there's going to be a dipole right here, right? And so what does that dipole really mean? Well, the X is going to be grabbing some of those electrons from that bond toward itself, right? So now this carbon is going to be a little bit deficient with in electrons, right? So if you have a carbon that's deficient in electrons, you kind of pull away from this carbon, right? And that kind of pulls from this oxygen a little bit, right? And so if you're kind of hogging these electrons, this hydrogen can leave more easily. And that depends on how electronegative this halogen is. Notice how when we talk about dipole induction, we only consider electronegativity. Only. When we talk about atom, on the other hand, we consider either electronegativity or size. Yeah, Amelia. So with that, notice how so Amelia brings up a good point. Everyone look at the chat and look you see HF, HCl, I can't select on HCl, HBr, and HI, right? Notice how now, since we're talking about the halogen being the atom, now your halogen is the atom. It's not the dipole induction part, right? Now we're going to be talking about size. Does that make sense? Because now we're talking about these atoms over here as being your atom. Does that mean need more clarity? Do I need to? Let me know. Does this make sense? Give me a green check. Give me a red X. Yeah, I heard that.
Girl, we are literally gonna.
So notice how here, this is your atom, nitrogen, versus oxygen, right? By the way, if you have your mic unmuted, try to keep yourself muted so there's no background sound.
Like, not that I'm not enjoying the help, because I need it, but like, holy shit, this is like so long.
Is this making sense?
Been here for 3.5 hours, like.
It's always atom and dipole induction that gets confusing. When you talk about atom right here, you only talk about the atom that's connected to the hydrogen, the one that's connected to the acidic hydrogen, right?
Sorry.
And then when you talk about dipole induction, that's kind of like outside of the atom. So if this is, let me go green, if this is your A, your atom, this is going to be your dipole induction. Everyone see that? Yeah. Okay. So number 13 might be a little hard. Don't worry about the explainer answer. Just try to get the equilibrium arrow. And think about it. So just say if it's going to be favoring the right or if it's going to be favoring the left.
If you're wondering what song I was gonna sing you, I was gonna sing you a song from Madagascar 2. But then I got embarrassed. I hated her.
Emily, do you mean condensed formulas in general or like pertaining to this question? Oh, like in general, yeah.
Yeah.
I mean, you won't need to know like the rules for condensed formulas. Just know how to like read them. Get some water.
Sorry, Allison.
Okay, what do we think this
I'm
is?
recording for my friend Allison, so I can't really talk.
Is it favoring the right or the
I'm
left?
starving. Can we have early dinner?
Let me know when to start freaking making it.
To the left?
Love you.
Alright, just text me when it's time, because if you're...
It's actually gonna be the right. So,
Right, I don't know how.
notice how this one's a little tricky too. So, notice how, yes, we do have our atom being nitrogen, right? And over here we have the atom being carbon. And we know that nitrogen is more electronegative than carbon, so it should look like NH3 is a stronger acid. But at the same time, remember how we have resonance? So this is why I always say, what do you call it? This is why I always say those cardio guidelines, they're guidelines. They kind of like guide you toward it. It's not totally perfect, but it helps, you know. Reason being with this is that remember how we can say that this negative charge can kind of be delocalized, right, onto both of these oxygen atoms now, right? By the way, side note, doesn't this kind of look like a crab right here? Kind of looks like a little crab. Yeah, so yeah, if you, even though you have a carbon here, this resonance, all this resonance over here, that's going to be kind of like trumping that that nitrogen, you know. Actually, what's crazy is, even though this is a carbon, the pKa is going to be like, just, I don't know, around like 17 or something, maybe 16, 17. No, you'll have, actually, I'm not sure. People were saying there were some fill-ins for the exams, but I don't think he's ever going to ask you to explain your answer.
Can you explain that one again, Randy?
Yeah, so we have a carbon here as our atom, because we're looking at the two acids, right? So the one circled in blue are the two acids, okay? So we have a nitrogen over on this side, right? And a carbon on the other side. We know that nitrogen is generally more acidic than carbon, but since we have this carbon being attached next to these double bonded oxygens, that's going to make it very, very much more acidic. Because remember how, since you can have this this resonance right here that I'm highlighting, since you can have that resonance, it'll just be easier for that hydrogen to leave, because resonance is going to make something more stable, right? And more stable bases. Yes, Yassine. Every equilibrium arrow, they're going to be favoring the side that has the weaker acid. Because if you think about it, if you have a strong acid versus a weak acid, that strong acid wants to get rid of its hydrogen. And so it will, you know. It's more favorable for you to get rid of the stronger acid. I'll go to this. Do you guys want to start skipping a little bit and see, has this review been a little too long? Yeah, okay, let's skip a little bit. So over here, if you want, I can just quickly go over these. Over here, if you have something like this is a really strong acid right here, the -8 pKa. That's definitely going to favor to the right. So it's going to favor products, right? And then you know that HCl is going to be the acid. Because HCl is never going to be a base, you know? So this one's going to be B.
Sorry.
Everyone see that?
Okay,
Good?
I think it's good.
Yeah. So then something like 15. Okay, so really quick, what do we think this is going to favor? Left or right?
The left.
Yeah, definitely the left. Because over on the left side, this is going to be our acid because it has a lower pKa and it lost the hydrogen, right? And then on the right side, this is definitely going to be our acid. This has a much lower pKa, so it's a stronger acid. And so you're definitely going to be favoring the left side. Got that?
If we have a lower pKa on one side, we're always going to favor the opposite side. Like if
a lower pKa for the acid, yeah.
Okay.
Yeah. Because of course, pKa only shows like relatively, right? So, let's actually do this one because we didn't do much naming during this review. I'll give you a minute or so. Let me know what you get for this. Let me actually pull this one. Let me give a pull for this. No, I don't want to save. No, I don't want to save the results. So number 16, you have A, B, C, D, E. Okay. So I just opened it. Put in what you think it is. Yeah, so remember how this parent chain only is the parent chain if it's the longest. We can get 6 carbon chain, and that's going to be longer than 5, so we're not going to have the cyclopentene group being a substituent, or we're going to have it being a substituent rather than the parent chain. And so it's going to be better to number this way because we can get 2 on this rather than if we went this way, we would only get 3 as our lowest number. So this would not work. And so you would just guess 2 cyclopentyl, 4 methyl hexane, because hexane means 6, right? All good? Try this one. This one might be a little funner, more fun. Close. It makes me wait to close it, so just keep your answers. I'll have it pull up in a second. Okay, so give me answers for this one once you get it. Amines are just going to be these things. You have a nitrogen in there, that's going to be your amine. Okay, so we're super spread on this one. I think there's still about like 10 more people that can't answer. So if you haven't answered, give me an answer. Let me see how everyone's doing. Okay, so let me start going over basics before I go to this one. Oh, okay, I see what you mean. So that nitrogen is still going to be an amine, but the only thing that's different is that you have groups attached instead of having hydrogens attached. So of course those amines, they can be NH2, they can be an NH group. If you have other, yeah, exactly. They just have more groups. So yeah, we're like super spread on this one. Okay. So as I start explaining this one, try to see if your answer changes. So if I have something like this of course is just going to be 2-butanamine, right? Let me open up a new doc on this. Actually, no. Let me make it so that you can still see the question. So this is going to be just 2-butanamine. Okay. I don't want to write that out because it'll. Actually, no. I can type it. So this is 2-butanamine, right? 2-butanamine. And so let's say I substituted one of these hydrogens and I made it a methyl group. Okay. So nothing changed to the parent chain because it's still the longest thing. We have 4 carbons, right? 4 carbons on the parent chain. Let me number those. 1, 2, 3, and 4, right? 2. So the way you name this is that extra methyl group right here. This is gonna instead of it being off the parent chain, it's gonna be off of the nitrogen. And so the way that you name that is you say N-methyl. Yeah, exactly. Now you say N-methyl, and then you still have 2-butanamine because remember the amine is still off of the second carbon, right? So let's say I had something like this. We had 2 methyl groups. Okay. Let me make this a category. Let's say we had 2 methyl groups. Both of the methyl groups are coming off of the nitrogen. So how would we name this one? Yeah, exactly. So of course, never forget the dimethyl. Yep. So N-dimethyl 2-butanamine. And if you want me to break this down, these 2 methyl groups right here are the N-dimethyl. Because again, both of those methyl groups are coming off of the nitrogen. And then the parent chain is going to stay the same because it's still 4 carbons. And then, you just have the nitrogen coming off the second carbon. Now where it gets a little bit different is what if I had a nitrogen coming off of number 3 also? And the way you would name this is you have 3 methyl groups and you would name them exactly where they're coming off of. So you have 1 methyl group coming off of the first nitrogen, or you have 1 methyl group coming off of the nitrogen. You have another methyl group coming off of nitrogen, and then you also have a methyl group coming off of, let me do this. You also have another methyl group coming off of the 3rd position. Does this make sense? So it would be N-3 trimethyl 2-butanamine. Exactly, Aisha. So Does this kind of lead you toward how you would answer number 17? Exactly. That's exactly it. So in this case, it might be a little bit harder to spot, but our parent chain is going to be as long as we can make a carbon chain. Remember that as long as the carbon chain includes the amine, as long as it includes the functional group, you're trying to make the longest chain. And the longest you can ever make it is just 3. Okay. So letter A, this says ethanamine, so you can cross that off, right? Letter B, this says butanamine, you can cross this one off. And so now we're between all of these. And all it really comes down to is where is the nitrogen coming off of? So to break it down even more, propane, right? That's my blue. And then the amine is going to be green, propane, amine. And then I have 4 methyl groups. One coming off of an N, another coming off of an N, and then one coming off of the second position. Trimethyl. Does that help when I break it down like that? Yeah. Yeah, so that's how you break down those types of names. Okay, so no, I don't want to save the poll. No, okay. So let's skip around a little bit more. This one right here, I hope this is just like terminology. If you have eclipsed and staggered forms, so like Newman projection, those are going to be differing in conformation. Remember how you have like conformational isomers? It's the same exact molecule, same exact connectivity, same exact everything. But if you have eclipsed versus staggered, you're going to have conformational isomers, right? So that's the answer. Okay, so 19 might take a little bit also. Take your time on this one. I really, really recommend drawing out the molecule in skeletal form. First do that and then name it. Yeah, I'm gonna put up a poll. So again, just take your time. No rush, but the poll's up when you need it. Quick reminder, just stand, don't keep on sitting the whole entire time. Okay, so 6 people have an answer so far. I'll go over it when I get okay, yeah. I'll give you a couple more seconds and then I'll start going over it. Thing, there's a small distinction. Notice that this one is methyl and this one is ethyl. So a little bit spread, but we're getting there, I think. So I think the best way to write Newman projections into skeletal form is start with your two carbons that are like head on. So let's start with this carbon out here with this carbon in the middle, right? The way I look at these Newman projections is I think this point in the middle is going to be the carbon that's like toward you, and then this big circle in the back is going to be the one that's facing away from you, if that makes sense. So the way I would draw that is we have our red carbon right here and our blue carbon right here, right? And I'll show like purple between the bonds. This is one bond. And now we're saying, okay, what's coming off of this red carbon? What are the three groups that are coming off?
CH2, CH3, CH3, and H3C.
Yeah, exactly. So we have an ethyl group, we have a methyl, and another methyl. It's going to be those. Yeah, exactly. So we have, okay, so 1, 2, those are the two methyl groups that are going down, and then the ethyl group is going to be going up. See that? And so now it's coming off the blue carbon. We have two hydrogens, which we're not going to show because this is just skeletal. And then at the same time, we have another ethyl group coming out. Yeah. So does this look a little bit easier to name rather than all this crap over here? It's a lot easier to name this one, right? So of course we're just going to say, okay, 1, 2, 3, yada, 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 6, right? And then this is the 2. And so we have two methyl groups coming off of the 3 position, and it's hexane, so it's going to be a. You have to do that? We did nothing. This was just like how one question was over on the quiz. And then 21 is really, really similar also. So is it okay if we skip these ones, number 20 and 21, or do you guys want to do one more? Okay. So Megan, you can email me if you need to. So I can even explain over email. I can like draw pictures and stuff. So number 22 will be a pretty quick one. Try to think of what's the parent chain for this. What's the longest carbon chain you have? And I think after this, there's only 2 more questions. It's 5 o'clock, by the way, in case anybody has anything that they need to do at 5 o'clock. Heads up. So again, if this is if this looks weird still, just try to write it out in what do you call it? Skeletal structure. Yeah. So one way it's gonna be heptane, it's gonna be C.
Okay, shut up.
And so one way you can do that is think, okay, this is one carbon, this is another, 3, 4, 5, 6. Remember how the back carbon is the big carbon? And then 7. This is 7. Or you can even say, without looking at the back carbon, you can think this is 6 and this is 7. They're both 7. Yeah, parent chain just means longest chain. So this is going to be heptane. And again, if you wanted to, you can say, okay, this is my back carbon on the left and then front carbon on the right. My back carbon just has a methyl. Front carbon has another methyl and an ethyl. And then 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Yeah, this would be how it looks like if you drew it on this skeletal. Yeah, Ken's got an accent too on the. I never do that. Okay, so there's just 2 more questions. Let's do number 3, 23 actually. By the way, A is besides this right there. But this was another question that I got wrong on the exam. Oh no, this was on a quiz actually, but nonetheless, no clue. Grace, do you mind reading that for Mike? Thanks. It's a weird question, but try to think it out. So what do we know about eclipsed? What does eclipsed mean? Yeah, pretty much overlapping, less stable, right? So we can think of the Newman projection of cyclohexane. By the way, I think I picked like 4 on this one. I had no clue. So we can think of cyclohexane. So you have this, right? You have a hydrogen coming out. I'm not going to draw all the hydrogens. All the bonds that I'm showing are just going to have a hydrogen, okay? No, that's actually not it's going to be going straight up. And then down, this is to another carbon right here. Then this is to another carbon. And this will make sense after a second. Does this look familiar? Right? Yeah, so in case it doesn't look familiar, you have this whole thing. This whole thing, right? If we think of this carbon and this carbon being these 2 carbons, right? And then think of these 2 carbons right here in green are the back carbons, right? So that's just what it's saying, right? Do you see how everything is staggered? Every single hydrogen is going to be staggered, right? And so the amount that are eclipsed are going to be 0. Another way you can kind of think of this is cyclohexane is the most stable out of the, cyclopropane, butane, pentane. It's the most stable because there's no eclipsed hydrogens at all. Everyone good on this? All right, cool. And final one, let's go with number 24. I don't think he's gonna ask you about a different cyclo one. I know cyclopropane has eclipsed hydrogens, a lot of them, but yeah, I wouldn't worry about that. But good question, really good question. Yeah, so Murray, a boat conformation is going to have a lot of eclipsed hydrogens. And I can kind of try to show that. Sorry if this is going over. I just want to see if there's a way I can try to depict something. No, probably not. Okay, never mind. Go on. Are we good with this one? Give me a green check if you're good. Yeah, this one takes a little time. So what were the two things that I talked about with ring clips? What's one of them? Equatorial always switches to axial, right? And then, yeah, then directionality. What about directionality?
They don't flip.
Yeah, it always stays the same. So the biggest one is directionality. That you can start crossing a lot of them off with just directionality alone. So if I have this guy, I have let me zoom in a little bit because you already know the answers. There's 1, 2, 3, 4, 5. So I have a methyl group going down, a methyl group. Oh yeah. Another thing to note is that and I hope this goes without saying, but what do you call it? How far away these groups are from each other, that has to stay the same too. You can't get constitutionalized in those just from a ring flip. So let's start with just this. We have two methyl groups going down, and they're one carbon away from each other. Okay. So if we look at right here, these, first of all, they're not both going down, and they're only one carbon away. There's no carbon between them, so we can take out 1. Everyone see how I did that? Wrong directionality, wrong connectivity, and so we can take out number 1. And now number 2, right? Number 2, they are one carbon away, but one of them is going up and one of them is going down. We're just looking at the methyl groups right now. And that's just something I picked. I just thought, okay, there's, yeah, sweet. So I just thought, okay, there's 2 methyl groups. Let me just do that one first, right? So I can take out number 2, right? How about number 3? Same exact thing. 1 up, 1 down. So I can take that out, right? And then, honestly, even number 5. Okay, I guess I picked one that just so happened to give me the right answer. You can keep on doing this. If you were to say, okay, these 2 ethyl groups have to be right next to each other, then you would be between, 1, you'd be between 4 and 5, right? But again, this one, you have a methyl going up and a methyl going down, so you can take that one out too. And so we're just going to be left with 4. Does everyone see how I got that? Cool. Are there any other questions at all? Yeah, exactly, Amelia. This is the rest of the whole sheet, so we went over this whole entire thing. If there are no other questions at all, then I think, yeah, no problem, guys. I think this should be it. So.
Actually, I have a question. Do we need to make an appointment with the proctor for the upcoming exam?
Ooh, I've actually never used Dr. U. Okay, someone's saying we don't. No, I don't know that, actually.
Actually, on the syllabus, it's saying that we need to make an appointment for the exam and the final exam, but not for the quizzes.
I don't know. I really don't know. Someone's saying that he posted a link. Yeah, you have to download an add-on. Yeah. I'm sorry, Naseem, I don't know.
That's fine, thank you.
Yeah. So people are saying you can look at the office hours. Yeah, do you have Dr. Trivedi or do you have Abraham?
Dr. Trivedi.
Okay, yeah. His office hours, he there's like a link on his Moodle. There's yeah, no problem, Jessica. I'll see you later. Yeah, you can check his office hours on Moodle, and he has a link on there. Yeah, of course, yeah. So if you ever need to email me, just email me. Like, even if it's the night before the exam, I don't mind. Yeah, so again, the questions and the answers of this are going to be on eSpace. I don't have answers, or like, I don't have explanations on there, but I can put this one on there. I can put this whole annotated thing on there. I can just save it, and then, I'll put this, and I'll say it's like annotated, So, Hamza, it's 25 questions. I don't know about that, Sean. Or Kent. Yeah. Yeah, if
Yeah, please, someone real quick who's used ProctorU, like, explain. I understand the add-on, but going along with what Kent just said, I've never done ProctorU. You just take the exam and they want you, or what?
I really don't know. I think it looks like it, because it looks like you just start the exam anytime on Monday, so.
Okay, not specifically you, Randy, I just didn't know if anyone else knew. We just open it and go.
I see what you mean, yeah.
I took the exam on ProctorU, and from what it sounds like, you just open the exam on Moodle, and then you open the extension for ProctorU, and then the minute you do that, the ProctorU will enter the key, and then it'll just open up and have you verify yourself with your ID and stuff.
Okay, and then do we have to show our workspace? Do you guys know, we're not cheating or something like that? Okay. Okay, thank you guys.
Yeah. So yeah, I'm hearing you. They tell you what to do. So. So yeah, I'll see you guys later. I'll see you probably on Wednesday. There's no SI on Monday. So Monday at 5.